Good morning. This is Mr. Herman here with your remediation, which was going to be on algebraic proofs. Now that we've looked at some geometric proofs, we have these ideas of what geometric proofs look like, of what algebraic proofs look like, and we're going to kind of try to relate these together to help build our ability to solve algebraic proofs as well as to solve geometric proofs. So before we start, with doing any of these proofs on the pretest, I do want to briefly review what our possible reasons are going to be for algebraic proofs. And so if we recall, if you have your remediation from a couple weeks ago, had that long list of all the possible reasons. So I'm just going to go ahead and list them that we're going to use here today. And we're going to start with, so there's our reasons. Okay, and we have some of the basic ones. So we have add or addition, we'll use that. Addition or subtraction. We have division, multiplication. All right, move that onto the screen a bit better. All right, we also have the distributive property. That's going to come up frequently. And then we have the symmetric property. Okay, and we might see the symmetric property today. We might not. It's one of those that it's kind of simple in what it is, but it is important to be able to show it. Okay, so when we do an algebraic proof in our statements, if you remember, and also thinking back to our geometric proofs, they are when we are going through the steps. Okay, so we're using our math notation like we used in our geometric proofs. And then our reasons are saying, why did we do what we did? So if we relate this to our geometric proofs, we're essentially just showing our work to how we get to our answer. In a geometric proof, you're showing your work to see how do you know that these are congruent. And even though we could maybe do some of this math in our head, we need to show it out. Even though we might know if two triangles are congruent, we still have to show that out as well and say why we know that. So let's go and start with number 1 here. And when we are trying to get our proof here, we have x by itself. So that's our ultimate goal here. Okay, so we always have to start with our given. All right, so we saw that in our geometric proofs. We saw that in our algebraic proofs earlier, and we're going to continue to see this in any proof that we do. We have to start with the given. Okay, now, since x is here on the left side, I'm going to move my x's onto the left side first. So minus 7x minus 7x. Then I have negative 6x minus 9 equals negative 15. Okay, and what did I do to get to step 2? We did subtraction. Okay, now, I'm still trying to get x by itself, so I'm going to move our minus 9 right here. So I'm going to do the opposite operation, so plus 9 on both sides. So I have negative 6x equals negative 6. In order to get to my third step, I did some addition. And then I'm going to divide by negative 6 on both sides to get my last statement of x equals positive 1. And how did I get to x equals positive 1? We did division. Okay, so we're basically just showing our work in the statements, and we're saying why we were able to do what we did in the reasons, just like our geometric proofs and just like our proofs before. All right, let's go ahead and move on to the second problem here. Okay, so once again, we're starting off this problem. We got to have our given. So I'm just going to copy down what we've got for our given here, and our reason that we know that this is true is because we're told that it's true. Let's get a little refocusing on here. There we go. Clear up the eyes this morning. So when we're solving this equation, we're trying to prove this equation, we want to start with things that are not with the x first. Okay? So even though I see a fraction there, I don't really want to touch it. Now you could touch it and do some work with it, but it's a little bit more complex. Okay, so I'm deciding to choose to to add my 3. I want to get rid of this minus 3. So I'm going to do my opposite operation. So I see minus 3. I'm going to do plus 3 on both sides of my equal sign. So that's going to give me negative 5 on the left equals x divided by 2. In order to get to that step, we performed addition. Okay. Now, when we're moving from this step, we want to get x by itself. With my x I see, we're dividing by 2. So like we've been saying, we want to do the opposite operation. Okay. And the opposite of division is going to be multiplication. So we're going to times 2 on this side, times 2 on this side. Okay. So then if I have times 2 divided by 2, that's going to go away. I'm going to give x by itself. And then 2 times negative 5 gives me negative 10. So that's my third and final step. And we did we did multiplication here. Multiplication. All right. And then we got to our prove statement at the end. Okay. So let's go and do one more together before you go ahead and work on your notes on your own. And this one looks a little bit different. We've got some parentheses here. So we've got to use one of the other properties that we have not mentioned yet. Okay, it's going to be a lot of fun here. So we've got 11 equals negative 1 times c plus 9. Once again, we have to start with our given. On the post test today, if you're like Mr. Herman, Mr. Gibson, Ms. Kirchhoff, I do not know how to do an algebraic proof, but you know what? I'm going to give it a shot. I'm going to write down the given. Okay? If we're writing down the given, that's going to give us some points here. Okay? We want to see that you're making an attempt. Okay? So, what we're going to do first here is we want to do we got parentheses, distribution. Okay, we got this negative 1 out front in front of our parentheses. If we think back to doing distribution earlier this year and last year, we know distribution means we have to multiply. Okay, so that negative 1 is going to get multiplied by the c. Okay, and when it gets multiplied by the c, it's going to have us negative c. And then this negative 1 also has to get multiplied by the plus 9. And negative 1 times plus 9 is negative 9, not plus 9. I see that mistake made a lot. And then this left side is just going to stay as 11. Okay, so that's the second line in our statements. And what did we do there? We were able to use the distributive property. Okay, a good rule of thumb is whenever you see parentheses, you're probably going to use the distributive property. Okay, it's a good bet. So let's go ahead and get down to our third step here. Okay, and we're trying to get c by itself. So I'm going to go ahead and, let's see, I'm going to add my 9 to the left side here. So plus 9, add it on the left side. Also have to add it to the right side. Okay, can never forget that. If we do it on the left side, got to do it on the right side. You have to keep that equation balanced. Okay, so that's going to zero out. 11 plus 9 is going to give us 20 equals negative c. Okay, and we did some, we did some addition there. So we'll go ahead and say our reason is addition. All right, now I see something here. We got a little situation going on. We got c on the left side, but we got negative c on the right side here. We got negative 20 on the right side. We got positive 20 on the left side here. So we're going to have to do a couple things. Okay. So first off, we always want our variable to be positive at the end. Okay. As we're trying to prove a positive c. So if we've got negative c, we want to make it a positive. We can think about this negative 1c that we multiplied. This negative 1 multiplied times c up here. So we're going to have to divide by negative 1 on both sides. And that's going to give us a positive c equals negative 20. Okay, and we see we did some division here, so let's go ahead and make sure we get that down. All right, and then we also need to make sure that our c is on the left side. Okay, because we're asked to prove that c equals negative 20, not that negative 20 equals c. Okay, And while you might be saying, Mr. Herman, that's ridiculous, it's the same thing, I don't disagree with you, but we're being asked to prove that C equals negative 20, not negative 20 equals C. And there's a real simple way to do this. If we think back to our property at the top, our symmetric property that we wrote down up here, remember from a few weeks ago on our algebraic proofs, that property says you can just flip your equation. Okay, so we know that if it's an equal sign, we can just take everything on the right, move it to the left, take everything on the left, move it to the right. So negative 20 equals C. We know it makes sense for C to equal negative 20, but we need to tell people that we know why that's true. Okay, and why is that true? That's because of the symmetric property. Okay, so you think back to the idea of symmetry, and the left side looks like the right side looks like the left side, and that's what we've got when we've got an equal sign in the middle of our equation. All right, so go ahead and work on the notes before you get those checked, before you take the post test at the end of class today.